Hello students, in this video we will continue the solving problems. Okay, the fourth one. In the following, state whether the set A is equal to set B or not. There are two sets given in the problems and we have to check whether the set A is equal to the set B or not. Let us recall the definition of the two sets are said to be equal, right? The two sets A and B are said to be equal if they have exactly the same elements, right? If they have exactly the same elements, then we can say that the sets A and B are the equal sets, right? So let's solve these problems. First one, read the first question. The set A equals to the letters A, B, C, D. And the set B is equals to D, C, B, A. D, C, B, A. You can observe both the sets. Both the sets having same elements. A is present in both the set, B present in both the sets, C present in both the sets, and D present in both the sets. Therefore, clearly the first one is A is equals to B, because A and B sets have exactly same elements. Right? Look at the second one. The set A equals to 4, 8, 12 and 16. The set B equals to 8, 4, 16 and 18. 12 is present in both the sets. 16 is present in both the sets. 8 and 4 are present in both the sets. But the 12 and the 18 are two different elements which are not present in both the sets. The 12 is present in the set A, 18 is present in the set B only. Therefore, clearly what is the answer? The answer is the set A is not equal to the set B. The elements of the set A and elements of the set B are not exactly same. They are different from each other. Therefore, your answer is the set A is not equal to the set B. Third one. The set A equals to 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, and the set B is given in the set builder form. The set of all x says that x is a positive even integer, and x is less than or equals to 10, right? So you can see what are the elements of this set. What are the positive even integers? The first positive even integers are 2, 4, 6, 8 and 10 has to be taken or not? Yes, 10 has to be taken, because less than or equals to, it means it may be less than, it may be equals to 10. Therefore, the elements of the set A and set B are exactly same. The difference is the set A is given in roster form, the set B is given in the set builder form. Therefore, no doubt the set A is equals to the set B. The set A is equals to the set B, because elements of the set A and B both are same, 2, 4, 6, 8, 10. Therefore, the set A is equals to set B. The fourth one, the set A is given to be set of all x says that x is a multiple of 10. X is a multiple of 10. What are the multiple of 10? 10, 20, 30, 40, 50, 60, 70 and so on, right? They are the multiple of 10. You can observe here 10, 15, 10 is multiple of 10, 15 is not a multiple of 15, 20 is a multiple of 10, 25 is not multiple of 10. Therefore, no doubt, what is the answer? Your answer is set A is not equal to the set B, because you can see if they are multiple of 10, then they must be like 10, 20, 30, 40, 50 and so on. But the elements 15 and the 25 are not multiple of 10. Clearly the answer is the set A is not equal to the set B. Okay, there are two more examples given in the textbook. Please, you can solve them. They are similar to the problems we solved in this video and some part of the last video. Okay students, let's go to the next definition. The next definition is subsets. Subsets is one of the important concept in the chapter sets. Therefore, it's very important to learn the subsets and the related things about the subsets. The definition is a subset, right? If a set A, the set A is said to be a subset of B, where A and B are the non-empty sets, right? For two non-empty sets A and B, the set A is said to be a subset of B if and only if each element of the A is also present in the set B. Every element of the set A present in the set B. In this case, where all the elements of the set A are the elements of the set B, in this case I can say that the set A is a subset of the set B, right? That is, definition is, if each element of some set A, if each element of the some set A is the element of the set B, if each element of the set A is the elements of the set B, then A is subset to B. Then A is subset to B, right? If each element of the set A belongs to some set B, then I can say that, then we can say that the set A is a subset of B, right? The subset is denoted by symbol this symbol is called subset. This symbol is called subset. Therefore, from the above definition, A is subset to B. A is subset to B, right? For example, if A is equals to 1, 2, 3, 4 and the set B is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, we will observe here that every element of the set A is the element of the set B. You can see all elements of the set A are present in the set B. In this case, the set A is a subset to the set B. The set A is a subset of the set B. So one more example. The set A, if set A is equals to 2, 4, 6, 8, 10 and so on, and the set B is defined to be set of all x such that x is a natural number, right? The set B contains all the natural numbers which are starting from 1, 2, 3, 4, 5 and so on. You can see here that the set A, the elements of the set A are 2, 4, 6, 8, 10. Think whether these elements are present in this set B or not. Definitely the elements of the A are present in the set B, right? All elements of the A are present in B. In this case, therefore, the set A is a subset to the set B, right? So these are the best examples we can give, right? For example, if a set contains the number of students, the 10 students from your section, from roll number 1 to 10, and the set B contains total number of the students of your section, then in this case the elements or the students of the set A, which are roll number 1 to 10, they are also present in the second set B, because second set B contains total number of the students of your section. It means clearly the set A is a subset to the set B. Okay, so these are the best examples of the subsets. I recall again, if all elements of the sum set A are also the elements or are also present in the sum set B, then A is subset to B. Note of this. Okay. In another words, if A is subset to B, In other words, if A is subset to B and if A belongs to B, the small a belongs to the some set A, then compulsorily A must be the element of the set B. So this is the technical expression of the subset. That is, if A is subset to B, then if A is element of the set A, then A must compulsorily be the element of the set B. It means the A is subset to B if and only if A belongs to A and A belongs to B. Provided A belongs to A, provided A must belongs to the set B. So in other words, we can say that the element which belongs to the set A must belongs to the some set B. Then only we can say that A is subset to B. Then only we can say that A is subset to B. Okay, students. So let us elaborate this in some deeper level. So remember that always if A is a non-empty set, remember always that if A is a non-empty set, then A is right here. If A is a non-empty set, then A is always subset to A itself. Right? If A is a non-empty set, then A is always subset to itself, provided the null set phi is always a subset to some set. Right? That is, null set is a subset to every set, I can say. Right? I can say that null set is subset to every set, because in every set, whatever the number of elements, if no elements are present in any of the set, that is, even if set A is being empty, then phi is always a subset of the any set. Okay. So in the next one, we will try to understand how to write the subsets. We will try to understand how to write the subsets. Okay. For example, if a set A is given to be 1, 2 and 3, then the subsets of the A are denoted by the letters A1, denoted by some letters A2, and so on, right? And how to construct the subsets, how to find the subsets of A, what are the subsets of A? Now you can see here. Okay, the subsets of this set where 1, 2, 3 are the elements of the given set A are present, then the subsets can be constructed by selecting one element at a time. Right? If you select only one element each time, then this can construct the subset. So these are the subsets. A1, A2, A3 are the subsets of the set A. Along with that, the more subsets can be constructed, that is the 4 subset A4, by selecting any 2 elements from the given set. If there are more than one element is present, then by selecting 2 elements at a time without repetition, then I can say that the A4 and A5 are the subsets of the set A. You can see I have chosen 2 elements 1 and 2. In this A5 subset I can choose 1 and 3. In the next subset I can choose the 2 and 3. See, there are no elements repeated, there is no subset repeated. You can observe all the 6 subsets, there is no subset repeated. The first 3 subsets of the set A, A1, A2, A3 contains only one element, single element of the set A. The subsets A4, A5, A6, they contains any 2 non-repeatedly chosen, any 2 elements of the set A. What about the next? You must go for the selection of 3 elements. Go for 3 elements. That is A7. So it contains 3 elements. Then the set A contains 3 elements. Then 1, 2, 3 are the elements of the subset A7. Then as I just told you that the subset is always the phi set, the null set is always a subset to any set. Therefore, the A8 will be the null set. The A8 will be the null set. Therefore, remember that by you observe these. What are the total number of elements? What are the total number of elements? 3 elements are present. What are the total number of subsets? 1, 2, 3, 4, 5, 6, 7, 8 subsets. Then is there any relation exist between the total number of elements of the given set A and the total number of the subsets obtained? Yes, there is a relation. There is a relation between the total number of elements of the set A and the total number of the subsets. The total number of the subsets of the A. Okay, you can observe here this side. You can observe here this side, right? If the total number of elements of the sum set A is P, right? What is P? P is the total number of elements of the given set A. N of A indicates number of elements of A. N of A indicates number of elements. You can see what are the number of elements? There are 3, totally 3. The numbers are 1, 2, 3, whatever. Total strength, total counting, the counts are 3. It means N of A is 3 here. N of A indicates number of elements of the set A. Okay. So as number of elements of the set A is P, then total number of the subsets, that can be constructed using the P elements. You remember always that is then the total number of subsets is always equals to 2 to the power P. The total number of the subsets is always 2 to the power P. Let us see some examples. Let us observe this one. Okay. So what are the total number of elements? 3. There are 3 elements. It means P equals to 3. If you put P equals to 3 in this formula, what you are going to get? You can observe 2 to the power 3. What is that 2 to the power 3? 8. You can count. There are totally 8 subsets are there. It means without writing the subsets of the given set, using this formula, one must be able to find what are the total number of the subsets without writing the subsets. It means if P is the total number of elements of the given set, then 2 to the power P is the total number of the subsets. Don't forget, this is extremely important for the point of CET, right? Okay. Let's use some another example. Let us check with some another example, right? So what happened if the total number of elements of the sum set is 4? That is the next case. If N of A is 4, then what are the total number of subsets? You can observe here that if N of A is total number of elements of A is 4, then the total subsets are 2 to the power 4, which is 2 to the 4, 4 to the 8, 8 to the 16. There are 16 subsets in there. 16 subsets can be constructed. Similarly, N is equals to 5, P is equals to 5, P is equals to 6, P is equals to 7. And even if N of A is 0, it means what? Set A is empty. Right? N of A equals to 0 indicates there are no elements. Number of elements of the set A is 0. Indicates no element is present in the set. Even in this case, the total number of the subsets is 2 to the power P, which is 2 to the power P. P stands for 0. 2 power 0 is 1 always. 2 power 0 is 1 always. It means even a set is being empty. Then at least one subset exists. And the subset is the phi. Right? As I told you that phi is a subset to every set. There exists at least one subset to even empty set. Note down this. Okay. So before going to problem section, let me recall the notations of the symbol. So this symbol shows that subset. Right? This symbol shows that not a subset. This symbol shows that you people already know belongs to. This symbol shows that not belongs to. Very good. Not belongs to. Not belongs to. Okay. So this symbol knows that equals to. And this symbol knows that not equals to. Not equals to. Right. So this is subset, not subset, belongs to, not belongs to, equal, not equal. Right. Fine. Okay, students. So let us understand this concept of subsets, the use of the symbols by using this example, right? So consider the sets phi, empty set, the set A which contains 1 and 3, the set B which contains 1, 5, 9, the set C which contains 1, 3, 5, 7, 9. Okay, so using these four sets, empty set phi, set A, set B, set C, let us see, insert the symbol belong, that is subset or not subset. We just came to know that this is the subset symbol, this is not subset symbol. We have to insert between these pair of the sets, whether they are subset of each other, whether they are not subset of each other, between each pair of the sets. Look at the first set phi. As the definition said that the phi, the null set, is always a subset to every set, right? You can take any set, whether the set is empty or non-empty, doesn't matter, but the null set phi is always a subset of the given set, right? So the phi is always a subset. The phi is always a subset. Whatever the set, A, B, C, whatever the set, the phi is always a subset to set B. Come to the set A. The elements of the set A are 1, 3. Elements of the set B are 1, 3. That is 1, 5, 9. Therefore, every element of the set A are not the elements of the set B. It means A is not a subset. A is not a subset of B. Coming back to the A and C, the relation between A and C you can observe. The set A contains 1 and 3. The set C contains 1, 3, 5, 7, 9. Definitely every element of the set A are the elements of the set B. Every element of the set A are the elements of the set B. Clearly A is a subset to C. You can see 1, 3 are present in the given set C. It means A is a subset of C. A is subset of C. B and C, you can see B and C. The elements of the B are 1, 5, 9. The elements of the C are 1, 3, 5, 7, 9. 1 present in C, 3, 5 present in C, 9 present in C. It means 1, 5, 9, the set B, the elements of the set B present in the C. B is a subset to C. B is a subset to C. So in this way, one must be able to find whether between the pair of sets, a set is a subset to the another set or not, right? So understand this concept carefully, practice. Okay students, now in this we will study the intervals as a subset of R, right? Intervals as a subset of R. Right? We know that there are different numbers are there. Natural numbers, rational numbers, whole numbers, integers, real numbers and all, right? So in all these, between some pair of numbers, between two pair of numbers, I can say that it is a particular interval. See, if I say your class is from 12 to 1, then the 12 to 1 is a particular interval of 1 hour. I can say that the interval is 1 hour. And it is between 12 p.m. to 1 p.m. Right? So similarly, between the numbers, see for example, there is a line, and there is some numbers A and B. There is some numbers A and B. Okay? So I will tell you there are two types of the intervals can be taken. Right? So I will first one I will show you through the picture. Second one also I will show you through the picture. Think that A and B are any two numbers, any two intervals, and between them there are many numbers are there. Like A and B, if I say 1 to 100, We know that between 1 and 100 there are different numbers are there, 2, 3, 4, 5, 6 up to 98, 99 and 100, right? So in that way. So if A and B are the any two numbers on the real line, if I say x belongs to open interval a comma b, so this can be read as open interval. Remember that this is open interval. This can be pronounced as open interval. If I say that x is some number which belongs to open interval a comma b, then I can say that x is less than a and x is more than b. X is less than a and x is more than b indicates x may be any number. X may be any number except the a and b. X belongs to open interval a comma b indicates that x may be any number between a and b. Between a and b, x may be any number in between, but not the a, but not the b. It means excluding the end numbers, the x can occupy, x can hold any number between the a and b. In the interval form, I can tell this same as x is less than, is more than, a is more than x is less than b. Right? I can say that a is less than, x is less than b. Then this interval which involved by the strict inequalities, this less than shows that strict inequalities, and this open interval indicates that excluding the end numbers, excluding, leaving. For example, if I say that the total strength in your classroom in the open interval is 1 to 100. If I say that the total strength in your classroom in the open interval 1 to 100, it indicates that there are only 98 students are present. I am only talking about 98 students. You might be one of the 98 students, but not the roll number 1, but not the roll number 100. It means except the first and last numbers, except the first and last points, the 1, 100 in the open interval indicates the total strength is 98. Right? So the open interval indicates if x belongs to open interval a comma b, then compulsory x is less than a, x is more than b. Sorry, x is more than a, x is more than a and x is less than b. It means between after the a before the b, after the a before the b. So x is always more than a, x is always less than b. You can see here x is more than a, x is less than b, x is less than b. Okay. So there are two representations. One is in the interval form and one is in the using the interval, that is the brackets. Next example, same example. If a and b are any two points, any two numbers, there exist some more numbers between the a and b. There exist many numbers between the a and b, and suppose if x is one of that, and if I say that if x belongs to close interval a comma b, where this one is called close interval. This one is called close interval. So close interval a comma b indicates that then x is less than or, that is more than or equals to a, and x is less than or equals to b. X is more than or equals to a, x is less than or equals to b. It means x can occupy any number between 1 and b, including 1 and b. right? If x belongs to the closed interval a comma b, the closed interval indicates that if x belongs to a comma b under the closed interval, x is maybe a, x may be a plus 1, x may be a plus 2, a plus 3, or x may be b minus 1 and x may be b. It means here I can write in the interval form that x is the a is more less than or equals to x is less than or equals to b. So this is the interval representation. The intervals as a subsets of R. As a subsets of R. So this is extremely important to remember that the a is less than x is less than b indicates x belongs to open interval a comma b, or in other way, if x belongs to open interval a comma b, a is less than x is less than b. Second point, if x belongs to closed interval, if x belongs to closed interval a comma b, then in that sense a is less than or equals to x is less than or equals to b. In reverse way, if a is less than or equals to x is less than or equals to b, then I can say that x belongs to the closed interval a comma b. Okay, x belongs to closed interval a comma b. Let us see some of the examples. Okay, you can see here that if x belongs to 1 comma 10 within the open interval 1 and 10, so if x belongs to open interval 1 comma 10, that implies x may be 2, 3, 4, 5, 6, 7, 8, 9. Observe this carefully. If x belongs to open interval 1 comma 10, then x may hold 2, 3, 4, 5, 6, 7, 8, 9, but not 1, but not the 10, because excluding the end numbers. Excluding the end numbers, or I can say that the same will be, so here 1 is less than x is less than 10, I can say in the interval form. In the interval form I can say that 1 is less than x is less than 10. Coming back to the second example. Okay, so in this x is belongs to the open interval 1 and close interval 10. Open interval 1 and close interval 10. It means excluding the 1, including the 10. Excluding 1, including 10. It means x can hold 2, 3, 4, 5, 6, 7, 8, 9, 10. From 2 to 10 x can hold, but not the 1, because 1 is excluded in the x. Therefore, open interval 1 to close interval 10. In the interval form, how we will write for this is 1 is less than x is less than or equals to 10. 1 is less than x is less than or equals to 10. Coming back to the third example, if x is belongs to the closed interval a 1 comma closed interval 10, indicates x can hold all the values between 1 and 10, between 1 and 10, including the 1 and 10. It can hold all numbers between 1 and 10, including 1 and 10, including 1 and 10. In the interval form, this can be written as 1 is less than or equals to x is less than or equals to 10. That includes all the numbers between 1 and 10, including 1 and 10, including 1 and 10. Hope this you understood. Including 1, excluding 10, every number. It means here x equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 10, because 10 has an open interval. Because of 1, it is closed interval. In the interval form, this can be written as 1 is less than or equals to x is less than 10. So these are the best examples of how the open interval and closed intervals are there. If x belongs to some of the all maximum varieties of the interval, then what are the values of x? And if the values of x are written, then what are the interval form? Interval form of the x. So these are the extremely important. Extremely important. Okay, students. Hope you understood all these concepts. So these are the extremely important for the point of CET, right? So in the next class, we will study the power set, the definition, the concept of the power set. For a given set, what are the total number of the power sets? What are the total number of the elements in the power sets? Okay, if a set is defined and if all the subsets are collected, then the construction of the power set is possible. Then what are the total number of the power sets for the given set. Okay, we will study. After that, we will study the universal set. We will study the universal set, and after that, we will go to the